All right, hello everybody. Today we're going to talk a little bit about pH. So, pH in chemistry is the scale used to specify how acidic or basic the water-based solution is. Acidic solutions have a lower pH, while basic solutions have a higher pH. At room temperature, pure water is neither acidic nor basic, and it has a pH of 7. So one of the things I wanted to do is make sure we start with pure water. So in each one of these glasses here we have pure water, and what we did was we boiled some red cabbage, right? And the red cabbage still keeps the water neutral but adds some color to it so that when we add the other things that we're going to add to the water, we'll be able to tell whether the pH raises or lowers based on the household chemicals that we have here today. So, let's see. I think we'll start with lemon juice. So this is just normal lemon juice that you would normally, use to add to your tea or whatever for flavor. And what we're going to do is we're going to add some lemon juice. All right. So, what you see here is that the red cabbage water solution went from a purple color to a pinkish or light purple color. And what that means is that we actually decrease the pH in the water. Lemon juice is acidic, right? So acid seems to decrease the pH level in the water. Now next is the lemon juice, or lime juice rather, and we would suspect that the lime juice is going to have the same effect that the lemon juice did because they're similar acidic fruits, if you will. All right. So there again, we have the same effect, right? So, the purple red cabbage juice turned to a light red or pink. And I really can't tell whether it's more or less acidic, because the colors do appear to be, roughly the same. So let's see what happens when we add household vinegar to the red cabbage and water solution. So do you think that vinegar is acidic, or do you think it's a base? Let's see. All right, so normal white distilled vinegar that you would use in your kitchen also has the same effect that the lime juice and the lemon juice had, which means that all three of those have acidic properties. Now, the next thing we're going to do is we're going to add normal toilet bowl cleaner. All right, so you see it's having a little bit different of an effect. And most of your household cleaners are a base, right? And if you look at the bottom, you can see it's kind of greenish down there, and then it's more of like a brown up towards the top. It had a totally different effect than the acidic household chemicals had. So what happened here? Did we decrease or increase the level of the pH in the water? Well, what we actually did was we increased the pH level of the water. So one last household chemical, right? So the toilet bowl cleaner also has bleach in it, and this is a bleach spray that you would use for sanitizing your home. Let's see here. All right. Not having much of a color change, so we'll just add some more and see if we can get it to change. All right. Well, it'll probably be easier then to spray it, then let's just pour some in here and see what happens. All right, so it is beginning to have a similar effect that the toilet bowl cleaner did once the mixture is correct. And it's turning like a brownish color, which means that we raise the pH in the water once again. Now, if anybody has ever owned a swimming pool, normally we would test, you buy a swimming pool test kit for chlorine pools. I know a lot of pools that went to salt water today, but the older style where you would use chlorine, we would test in a similar way to see what the pH levels in the water are, so we know whether we need to add some uric acid to the pool, which we know acids lower the pH, and bleaches and chlorine, if you will raise the pH level of the water. And you got to make sure those things are right in order to prevent algae from growing and things of that nature in your pool, to keep it nice and clean looking. I hope you enjoyed this demonstration today. Have a great day.